Good morning. I'm Jonathan Mills. Thank you for having me. I work for NASA Goddard Space Flight Center. There's a lot of different, NASA centers, so we do have to kind of qualify because they're not necessarily all coordinated. I don't represent, what NASA Ames is doing, for instance. At Goddard in Maryland, we have the Computational and Information Sciences and Technology Office, which is the worst name ever. It's called SISTO for short, but we mostly just call it Code 606. We are the parent organization for the NCCS, which is the NASA Center for Climate Simulation. There's also an NCCS at Oak Ridge, right? Doesn't Chris Layton work for them? So don't get us confused. Dr. Dan Duffy, who's my boss, is the chief of SISTO, and Laura Carrier is the head of the NCCS. And I am an HPC and cloud engineer, and my new role is sort of architect. I have a partner in crime, Robert Budden, who couldn't be here today. He's got a newborn son, so good for him. So disclaimer, I am like most NASA workforce people, I am a federal contractor. I work for a small company called AdNet. They're great. So, the usual disclaimers apply. What I say here and the ideas I put forward may not necessarily represent the views and attitudes of NASA, but my slides today have been approved by civil servants, so that's good. Yeah. All right, so next slide. Beowulf. Who's going to the Beowulf Bash next month? Exciting. So the Beowulf cluster was invented in 1994 at NASA Goddard Space Flight Center. And it was housed right down the hallway from my old office, actually, in Building 28. Using commodity off-the-shelf parts, etc. Yeah, it changed the world. Thomas Sterling, he's a professor here, I believe, at Indiana. No longer. Okay. All right. Well, that's cool. So, we did also play a small role in helping to start OpenStack, along with the help of, say it with me, rack, space. Okay. I had to start the day with a pun, right? It's the only way I'm going to get through this. So, the story. NASA contributed the Project Nebula, and Rackspace contributed Swift, of course, and that's how things got going. But in 2012, NASA kind of walked away from OpenStack, and we didn't do it for a long time. And when my team built the first large-scale OpenStack cluster at Goddard in 2016, 2017, that was the first time I know of that anybody at NASA was really running OpenStack in production. But, we're not heavily invested in OpenStack today, and we are invested in the Beowulf cluster. So 30 years on, most HPC centers still running Beowulf clusters. This is Goddard supercomputer. It was architected in 2006, and it is still the same architecture. The hardware is refreshed annually, but it's good. It's a well-maintained system, but its configuration is rather manual. The design is entirely static. In point of fact, changing it at all is pretty much kind of anathema to the whole philosophy. It's a production resource, and we don't change it. So, we're 15 years, give or take, into the cloud era, for lack of a better word. And we've seen a lot of revolutions come in computer science in this century, this new century. I mean, we've seen the DevOps revolution. There's been Agile, there's containers, GitOps, others. We kind of didn't do it. We kind of skipped all that. We're still doing a Beowulf cluster. There may be some Puppet in there or another kind of CM, but sometimes not. Sometimes there's Git versioning of important files, but also sometimes not. And a lot of times sysadmins just peedish around doing live commands on wide swaths of nodes. I think it's fair to say we have some technical debt. Every word on this slide is a reason or a rationale, an excuse to keep going in the exact same direction, unchanged. And I'm not saying they aren't good reasons. The one I hear the most is simply that we're too busy, and that is true. Busy supporting operations, keeping production systems online. And we run pretty lean. We're a small team. I also hear that the current systems don't need to change because they're working just fine for our customers. And there's a lot of truth in that too. I'm sure our users would like a faster file system, but wouldn't we all? They'd probably love their jobs to stay in the batch queue less time, but everybody wants that. All these reasons can be totally valid, and yet they also do nothing to sort of curb that tide of technical debt. And it's leaving us less and less prepared to face the challenges of the future. So we need to transform. We have serious power constraints. I mean, that means we'll never be able to compete on scale alone. Our supercomputer is smaller than CERN's Ceph cluster. I mean, we're never going to be as large as NASA Advanced Supercomputing, or NAS, out at NASA Ames. So we need to diversify. We need to make our systems more flexible, less static. We need to be more competitive by offering more features and more capabilities. We've got to do more with less. Long lead times, supply chain issues. It's taking us too long to build new systems. These are all pressures that we're feeling, but it would help if we had the ability to use more, consumer off-the-shelf commodity kind of stuff. It would be great if we didn't always have to buy from the same two vendors. So, we're all interested in things like Ethernet instead of InfiniBand. What can we do with Rocky V2 or the Ultra Ethernet Consortium? Our new users increasingly want to work with Python code and an IDE like Jupyter Hub. And it's not easy for us to do that with our current architecture. We can't host a web-based service off of a Beowulf cluster. We can host a web-based service off of our small OpenStack cloud, but the supercomputer and the OpenStack cloud are in different network zones with different security postures. So the two can't really easily be made to speak to each other. And yes, that's very much on purpose. That's what's by design. New users increasingly want to work with containers, but we have poor support for containers on our Beowulf cluster. It's mostly old libraries that are part of SLES. We have old versions of Singularity. There's no network path to reach a container registry from inside our cluster. In fact, there's no network path to reach our own GitLab server. New users increasingly want to work with generative AI. We don't really have a file system that is fast enough to supply the data to keep the GPUs busy. And you can only access, how much time do I have left? I got to speed up. Okay. Okay. Halfway through. New users increasingly want to work with generative AI. The only access to the GPUs is via Slurm. So it's not really conducive to running something like Olama, for example. You can't access any kind of web-based interface that fronts the model. I'm just touching the surface. I mean, we have excellent security, and that's good, but it's what passes for excellent security in 2006, right? It's your standard defense in depth, static firewalls, lots of different zones. To get from here to here, you may have to hop through a dozen different firewalls. And those firewalls are, no, not API driven or programmable. We can't even SSH to them. It's all out of band connectivity. Our firewall changes are measured often in weeks rather than minutes or seconds. So you can see that that's not really great for cloud computing. Excuse me. Mike Lowe, if you're back there, can you bring me my water? My throat's getting dry. Sorry. I should have brought it up here. Great, thanks. Almost back in business. This is Neil Armstrong's first photo from the Apollo 11 landing, taken from the lunar module window. So, you know, they just made it. He's just about to take his one giant leap for mankind. 7 years earlier, September 1962, John F. Kennedy, speaking to an audience of professors and students and scientists, much like this crowd. He's gathered at Rice University, and midway through his speech, he just blurts out, why does Rice play Texas? And I love that line. It's a beautiful rhetorical device. I think he actually ad-libbed it, but you know, he's simultaneously cajoling his audience, who, by the way, they're gathered at the football field. That's why it's a football reference. But he's also praising them for their courage, their audacity. Now that Kennedy's really got their attention, you know, he pivots right to his point. He says, "We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they're easy, but because they're hard. Because that goal will serve to organize and measure the best of our energies." That last part kind of lives rent-free in my brain. I go back to that over and over again. Did we really need to go to the moon? Yeah, in and of itself, no. But in so doing it, we taught ourselves the skills that we needed to be good at space. Because that goal will serve to organize and measure the best of our energies and skills. You see where I'm going with this. We need to transform our HPC center. If we don't, we will fail to rise to the level of tomorrow's challenges. We'll drown in our technical debt. We'll become obsolete, overcome by events. We need to transform, and to do it, we need a bold challenge, one which will inspire us, one which will serve to organize and measure the best of our energies and skills. Whoops. So here's our vision. Starting now at Goddard Space Flight Center, we will begin down a path which will oversee a transition of all of our HPC work to cloud-native platforms. It's going to be a huge leap for us. It's a big change from running static Beowulf clusters. It's scary. Some of these systems will be on-prem. Some of these systems will be in commercial cloud. But we will adopt the same tools and techniques to manage infrastructure and workloads in both places, whether we're working on-prem or in commercial cloud. To make this possible and relieve the burden on our operations teams, we have formed a new group within Sisto. It's separate from operations, and it's just going to be focused on research and development and figuring out how to build this new system. And then we will slowly train and backfill our operations teams and start to move HPC workloads over the span of a few years. Crucially, the advanced technology team is all former operations engineers, people like myself. So as we apply what we've learned, we'll have sessions with our operations teams to show them what we're doing and elicit feedback. Now I'm running low on time, but the core concepts, we will use infrastructure as code to deploy these HPC systems, Crossplane or Terraform or what have you. That's going to be talking to the various APIs and OpenStack, of course. The control plane network is going to be BGP, a routed topology, and that's to open our minds and free us from the constraints of sort of layer 2 networking, right? It's going to allow us to have layer 2 adjacency at different locations. SDN, automation at the edges, right? That's going to be great. So we can bring up layer 2 segmentation at the edges and not have to plumb new VLANs through our core, for example. We're going to replace XCAT and use OpenStack Ironic to deploy baremetal. We're going to have 400 gigabit networking to the node, and we're going to have NVMe storage. And that's going to be able to drive the AI pipelines to our GPUs. And we will have DGX, I think H200s. We're going to have several of those. And Ceph for a tier 2 storage, scale out storage. It's going to replace an NFS archive that we have now. Tier 1 storage, of course, all NVMe. We're going to test different file systems. I need to be on the right slide. Weka, Quobyte, Vast. I'll give you guys a minute to absorb this because I was on the wrong slide. All right, moving on. Security, we got to change our security. We can't have these static firewalls everywhere. We want to do DevSecOps. And a big part of that is going to have an image pipeline, CI/CD, that's continually hardening our images all the time with all of NASA's baseline security controls. That means as soon as we deploy something that's already secure, it's always patched and up to date. We won't probably patch in place. We will just redeploy again and again and again. Zero trust architecture. So we'll eliminate these trusted network zones and the static firewalls, and instead, I will have strongly validating a user to every service. That's what ZTA is. The DoD is all about it ever since Edward Snowden. You can imagine why. The DoD is paving the way for zero trust. NASA's going to have to adopt it. A big part of that, we have the cloud RBACs, right? Role-based access. That's going to be tied via OpenID Federation to agency-controlled ICANN. Time is up. So I'm going to zip through my last slide and then conclude. So this is the timeline. And you can see we've already done some stuff. The architecture design, researching hardware, the procurement, rack and stack and configuration, we've already done it. And we're getting ready to build an undercloud with KOV. Thank you, Stack HPC, for your help. Ceph storage, the image pipeline in 2025, next year, we get into the serious work of making it do HPC stuff. You see all that kind of stuff. 2026, we go sort of pre-operational or quasi-operational. We'll probably have some operational workloads, but we'll have stuff in the old cluster too. And through attrition, we'll slowly move over. We'll see how it goes. End user adoption, you see. So we're making good progress and we're excited. And we have already solved the hardest problem in IT, which is naming things. So hang on. There it is. So looking forward to introducing you all in the future to Inspire, our new HPC system. Thanks for having me.